Looking to understand how to find the equation of a line or how to calculate position, velocity, or acceleration using real life data? Well, if that's the case, welcome to Math Tutorials 82, where we master together the skills that will set you up for success. So, how are we going to do this? Simple. We are going to use a real life example which involves a real plot of land and also a supposing or also assuming that we are driving through this plot of land to have a good glimpse of the land. And you might be asking yourself, so what are we gonna use? So we're gonna use the following. We're gonna use a car. So in this car, we have a flat land with some mountains in the backside. So I found the perfect spot that not only serves its purpose for this exercise, but also is comparable to the picture. This way, we will understand how to set up a grid, set up origin in the grid, determine position, velocity, and acceleration, as well as obtaining the equation of a line using real life data. So to start off, I'm going to perform a demonstration on how to set up a grid. So I showed you an image of a car going through a field that's overseen by some mountains. And so just to find the right location, I found one right here where you have a flat land right next to some mountains, as you can see. So this is a perfect example. So one of the things that we're going to look at is to see, the grid location-wise. How do we set up a grid correctly? So in this case, there is an existing longitude and latitude, as can be seen right here, which is 39.00 and negative 77.92, which tells us exactly where this is located. Now, if we were to create our grid, we would have to go to Google Earth, make some measurements, and determine where our origin is going to be. So our origin can be right here, it can be right here, it could be right here. Just depends on what your preference is. And so let's make this our origin. So if we do that, we can just use the measuring tool here. And let's make it our grid 200 meters by 200 meters. Let's say, so it's going to be a grid roughly like this. Of course, in this case, this plot of land is a little bit bigger than that, but this is just for demonstration purposes. So looking at it from more of a perspective, we determined that our origin was going to be right here. And so, but as you all can see, there is still more land here. And so we would need to be able to find the grid for this whole plot. So let's create one right here where we continue it. We would need down here, a little bit here, and somewhat up here. But let's keep it simple. So instead of going through the whole plot of land, we're just going to use these two grids and this one right here. And this last one right here. However, as you can see, we're still missing this little piece right here, so we're going to need to move the origin a little bit. So our new origin, which is right here, is going to be, in order to fit everything, it's going to be right here. So that way we cover this plot of land right here, this one right here, and this one right here. And so initially we had set up our origin right here. However, it would be simpler to place it right where we're going to be driving into the lot, which would be right here. Since we're going to be going into the lot and through the lot and eventually back into one of the roads. So having our grid origin right there will make things a whole lot easier for us. So this way, this would be our y. This would be our negative y. This would be our negative x. And this right here would be our x. So let's say we drove like this for the first 3 minutes, since we're looking at the land. Then we decided to drive up north a little bit like this for the next 2 minutes. Then we decided to go for the next 2 minutes like this. And eventually we decided to just drive back to the road. So it took us 10 minutes in total to drive through the entire plot of land. So right here we have that t is in minutes. And each of these squares is 10 by 10. So let's label the x and y right here. So it's all covered: 20, 40, 60, 80, 100, 120, 140, 160. This would be 20, 40, 60, 80, 100, 120, 140. So 20, 40, 60, 80, 100, 120, 140. So we know the following. We know position is equal in meters. We know velocity is equal to meters per second. And we know that acceleration is equal to meters per second squared. And we also have our time. So at t0, our position is 0, 0. So our position is 0 meters. And our velocity is 0, 0. Well, 0 meters per second because we're not moving. And our acceleration is 0 because we're not moving at all. However, since between 1 and 3, we have the following. Our position changed to 20/20, 40/40, and 60/60. So our velocity was basically, we do a little right triangle here for all of these three. We moved 20 meters in x, 20 meters in y. So our total distance for each of these was 28.28 meters. So our velocity is equal to 28.28 meters divided by 60 seconds, and that's equal to 0.47 meters per second. Our acceleration for T1 is going from 0.47 to 0 divided by 60, and that's equal to 0.0078 meters per second squared. Our acceleration for the other two times is 0 because it's the same velocity going from T1 to T2 and T2 to T3. And so now we'll see for our next combination, which would be T4 and 5, where we're going to be at 60, 80, and 60, 100. So in this case, our distance is 20. And here it's 28.28 meters. And so our velocity is going to be 20 divided by 60, and that's 1/3 meters per second. For T4, acceleration is equal to 0.33 minus 0.47 divided by 60. And for T5, it's going to be 0. That's equal to negative 0.0023 meters per second squared. So we're decelerating between T3 and T4 because the velocity went down. But we're keeping, and the acceleration is 0 between T4 and T5 because the velocity was the same. So now the following, which is T6 and 7. So T6, we're at 80, 110, and then we're at 100, 120. So using the little right triangle, we went 20, 10, and so that would be 22.36 meters. And our velocity is 22.36 meters divided by 60, and that equals 0.37 meters per second. And so our acceleration is 0.37 minus 0.33 divided by 60 here and 0 right here. That would be equal to 0.00067 meters per second squared. So right here. And then our final is 8, 9, and then 10. So right there, we have the following. We went from now 120, we went down to 100, then 140, 80, and then 160, 150, 70 in this case. So let's make T10 separate. So here we have a y of 2020. So we have that this is 28.28 meters. Velocity is 0.47 meters per second. However, we had a deceleration because we're going, well, acceleration actually. We're going to have 0.0017 meters per second squared. Here it's 0. Here it would be 10, 10. So that would be 14.14. Velocity equals 14.14 divided by 60. That equals 0.24 meters per second. And the acceleration is equal to 0.24 minus 0.47 divided by 60, and that equals to negative 0.0038 meters per second squared. So in other words, between T1 and T3, we had a constant velocity. We started by accelerating, and then we had an acceleration of 0 since we maintain a constant speed. Between T3 and T5, we decelerated because we went from 0.78 to 0.0023. So we decelerated and then maintained a constant velocity. Between T5 and T7, we actually accelerated. Accelerated since we went from from 0.133 to 0.37 in speed, right here. From T7 to T9, what happened is that we accelerated because we went from 0.37 to 0.47. So we accelerated right there. And then we had an acceleration of 0 at T9. And for the last one, which was T10, we decelerated from 0.47 to 0.24. So we had this deceleration right there. And we got back to the road. So we know that y equals mx plus b. And so what happens right there is that we can do the following. We have that for T1 through 3, y was equal to x because we were going through origin. So in this case, y equals mx plus b, but b was 0. And we have that m was 20 minus 0 over 20 minus 0, which equals 1. That's where we get this one right here. For T5 through 7, T5 through, see right here, T3 to T5, we have that this is non-existent and this is a constant. So in this case, it's x equals 60 since it's going through this straight line right here. Now between T5 and T7, we have the following. So when we look at our image, it's going right here like this, and we have that that's 70 right there. So we have B. So this is 70, and we have M equals right here 120 minus 110 over 100 minus 80, and that equals 10 over 20. That's 1/2. So our equation is, this is 1/2, is 1/2 x plus 70 for T7 through 9, y equals mx plus b. We have the following. M is equal to 80 minus 100 divided by 140 minus 120. That equals minus 20, and that equals minus 1. So this is minus 1. And for b, we're just going to have to go all the way back here. So we know that this goes all the way up here like this. And so when it hits b, it's going to be basically, we're right here at 100 and 120. So At 80, it's going to be 140. At 60, it's 160. At 40 is 180. At 20, it's 200. And at 0, it's 220. So we have that is going to be 220. And there you have the equation of the line for all of these. If you enjoyed this exercise, you get 3 gold stars. Just remember to look at the videos at the end that will show you how to calculate the different parts of a right triangle and how to calculate the slope of an equation. And, well, I guess I will see you in the next one.